Hello boys and girls, this is Mr. Kizik, and in this video today we're going to be talking about some triangle congruency statements. So remember, in the last section we talked about in order for two figures to be congruent, all the corresponding sides and angles must be congruent to each other. So therefore remember, all the sides must match up and all the angles must match up. However, with triangles it's a little bit different. It turns out with triangles, I don't need to know every single piece of information. I can give you some different things and we can determine if it's enough information to prove that two triangles are congruent to each other. So as you can see here, we've got some different things. We're not going to be doing all of it today. We're just going to be exploring these first two. So this first one is called the SSS exploration. But what does SSS stand for? It means, for a figure, it means side, side, side. In other words, if I look at this little picture here, if I tell you three sides of a triangle, like in this case here I tell you 6, 8, and 5. If I gave you those same measurements and told you to form another triangle, we want to see, do we get the same exact triangle? So again, in order for two triangles to be exactly the same, all the sides and all the angles must be the same. Well, we already know that all the sides are the same because I'm telling you that the three sides are the same in both triangles. So we just need to determine, will my three angles here, the 37, the 92, and the 51, will they be the same? So let's check. Okay. So I'm going to move this around here. Now, this program is not exactly perfect. It's a free web version online. It's called GeoGebra. In class, we're going to try to use a paid program. Hopefully, I'm able to get it because it does a little bit better than what I'm doing here. But anyway, alright, so I got this angle to be the same angle, A to be 37. So now what I need is, I need angle C here to be 51 degrees and angle B to be 92. So let's see, do we get that? And does it form a complete figure? So B, 92, 51. And lo and behold, look at that. I do get the same exact triangle. And there is no other way to rearrange this figure so that I get a complete closed figure and get different angles. And if I move that around, if I move that around, you can see I'm not getting a closed figure. Move that around, move that around. So this is a valid theorem to say that two triangles are congruent. If I give you three sides of a triangle and the same three sides from the triangle, we can say with 100% confidence that two triangles are congruent. So let's write that down here. Let's actually write it down in our notes. So take a piece of paper right now. So title it side, 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 or the SSS. And we actually call it postulate, not a theorem, because remember, we talked about postulate means that we assume it to be true in mathematics. So postulate says this. It says, if three sides of a triangle are congruent to three sides of another triangle, then the two triangles are congruent. Notice I don't need to know anything about the angles. If I just give you the three sides, we know that the two triangles are congruent to each other. Right? That's the first theorem. Let's look at this next one here. Now mind you, like I said, we're going to be exploring all these. Not all of these will work. Some of them will fail. Let's look at the next one. This one's called SAS. Well, if S means side, what do you think A means? Hopefully you thought about A means angle. So in this one here, and this is actually how the naming helps you, SAS. This one means if I give you two congruent sides, so let's say I gave you sides 7 and 6, and I gave you the angle that was between them, let's say in this case 97 degrees. Let's say I gave you those three pieces of information, so here we go, 7, 97, 6. Could my third side be the same? So will my third side be 10? And will my other two angles be the same here, 46 and 37? So let's check. Notice I cannot change this angle measure. Again, I am given this. This has to be 97. Thinking about this logically, this probably should work, right? If this angle here is locked, is fixed, then obviously this has to be the same length here. But let's just see. So I'm going to move this around. Remember, the angles must match up. And it says I have to have 46. So that's 46. So this length here should be 10, and angle A should be 37. Oops. And there you go. Like I said, free program. Unfortunately, not going to be exactly it. So, but as we can see here, I do match my triangle. I get my third side is 10. I get my two angles to be the same. And notice again, if I move this around, there's no other way I could get another triangle. I couldn't connect this up here. Yeah, I form a triangle, but I'm not connecting the vertex here. Now I have a different length. So this, again, like I said, doesn't form a congruent triangle because that's not the entire length of 7. I have to connect it right down here. And like I said, lo and behold, I do get the same triangle. So this is also a valid theorem. So let's write this down also. So we will call this the side angle side or SAS theorem. And it says this here. It says if two sides of a triangle and the included angle. That's going to become important when we look at later things here. And the included angle are congruent to two sides. Two sides of a triangle and the included angle. Then the two triangles are congruent. So as of right now, again, there'll be more later, but as of right now, these are two valuable theorems here to determine if triangles are congruent. First one, if I give you three sides of a triangle and those same three sides for another triangle, we can 100% confidence say they are congruent. Likewise, if I gave you two sides and the included angle of a triangle and those same two sides and that same included angle of another triangle, then we can say with 100% confidence that those two triangles are congruent. Alright, so that's basically the notes here. So now let's look at that worksheet here that you were handed out that says, there you go, that says SSS and SAS Notes and Practice here. So what we're going to look at here are a couple examples of how to use those theorems, and then using the theorems, how you can find other sides and angles here. Remember when I mentioned this in our last class with section 4.1 on determining if figures are congruent or not. When you're given drawings, you're not given everything. Using definitions like vertical angle or the reflexive property or that third angle theorem, using information like that, you might have to mark down the figure more. So for example, if I look at figure 1 here, I got two triangles. Hopefully you see I do have two triangles here. Is there anything else that I can mark down in this figure? Your answer should be yes. If I look here, I have this shared line. Well, what do we know about that? What do we know about shared lines? Well, if it's the same for both the left and the right triangle here, logically that has to be congruent then. So I would mark down that this side is congruent. Nothing else I can mark down. Now I'm going to look at the figures themselves. So if you would pretend like you cover up one of the triangles and you look at the other one, then you cover up that triangle and look at the other one, see what's marked down. So let's pretend I covered up the right triangle, and since you can't see me cover it up, I'll just cross out here. Alright, what can you tell me about the left triangle? There are three sides marked, right? 1, 2, 3. Alright. Now, let's cover up the left triangle here. What's marked in this right triangle? 1, 2, 3 sides. And they're the same congruent corresponding sides. So what does that mean? We have three sides of one triangle congruent to the same three sides of another triangle. Therefore, these two triangles are congruent. And how do we know? by the SSS postulate, by side, side, side. Because 3 sides in one triangle are marked with 3 sides in that triangle. Let's look at number 2. Again, is there anything else we can mark in this figure? And hopefully you said to yourself, yes, I've got vertical angles here, so I'm going to mark them, vertical angles. And again, the same thing. You're going to cover up one triangle, see what's marked, and then do the same thing for the other triangle. So if I look here, I have 2 sides marked, and we have an angle. And we want to make sure, is the angle between the 2 marked sides? And when I say between the 2 marked sides, I say, if I trace out the 2 sides that are marked, is the angle that I labeled here the one that forms where the 2 lines connect? And that is true. Alright, so I do have SAS on that side. Now cover up the left triangle. Do I have SAS on this side? And I do, because again, I got my 2 sides are marked, and I got the angle right in the middle here where the 2 sides meet up. So, what do I have? I have both of these triangles are congruent because of the SAS theorem. Let's skip down to number 5 here. So again, you want to say to yourself, is there anything else you can mark down? And hopefully you say number 5, there isn't. There's no shared line, there's no vertical angles, so I cannot mark anything down. I can't force these angles here to be congruent. I can't force these sides here to be congruent. Nothing says that I can do that. So there's nothing else I can mark down. So based on what I have here, I only have 2 sides marked in both figures. From what we learned so far, is that enough information? And it's not. Knowing 2 sides of one triangle doesn't guarantee me that if I know those same 2 sides of another triangle, they are congruent. So in this answer, in this case here, no, these 2 triangles are not congruent. Or at least we could say we're not 100% sure if they are congruent. Alright, let's skip to number 8 here. Again, is there anything I can mark down? And hopefully you said no, there's nothing else I can mark down here. So I'm going to see, do I have, based on the 2 theorems I know so far, SSS and SAS, do I have enough information? Well, on the left figure, everything looks pretty good. I have my 2 sides here, trace those out, and the angle, or the area where those 2 lines made up, is marked. So that's good. But if I look at the right figure here, I got my 2 sides, that's fine, but here's the angle. That's the wrong place. This angle should be marked right here. But again, I can't force that to be marked. I can't just say, oh yeah, that's congruent. No. Those 2 angles do not match up here. So therefore, we can also say that no, these 2 triangles are not congruent. Alright, so pause the video, and I want you to try the rest in this top section here. Just pause the video, and then unpause it, and I will show you at least 3 and 4 here, because this is going to be part of your homework. I'm not going to do all of it for you. Alright, so welcome back. So for number 3 here, hopefully you mark down the shared line. And then for number 3, you would see that both these 2 triangles have 3 sides marked, 3 sides and 3 sides. That is enough information, so these are congruent by SSS. For number 4, you have also marked down the shared line. And then you would see, okay, I got 2 sides in the angle for both triangles, and you want to make sure it is that angle between the 2 marked sides. In other words, where it meets up. And yes, woo, okay, hello. And yes, that's true here. And then again, I have my 2 marked sides of my other triangle. The angle is where the 2 meet up, so these are congruent by SAS. And again, hopefully you did do the other 2 problems, because these will be for homework. And we will go over next time in class. Alright, number 9 here. So if I look at number 9 and 10 and the rest of these problems here, it's asking me something different. Now I'm telling you what theorem that these 2 triangles will be congruent by, but there's something missing in order for that to be true. So you need to figure out what the missing piece of information is. And I highly, highly suggest when you do this, actually mark down your figures to visually see what you need to mark down, and then actually write it down. Just like before, you still need to mark down what else you do know. Any shared lines and vertical angles. And you'll see that with a lot of these patterns here. So if I look at number 9, I can mark down this shared line. Correct? I can say that FE is congruent to FE because they're both in both triangles here. So if I look at both triangles, I have two sides marked down. So what am I missing? I'm missing an angle. And a lot of students ask, well, does it matter which angle it is? Well, yeah, it does, because the theorem is SAS. It tells you in the name that the angle has to be between where the two congruent sides meet up. So here we go. This is what I would do. Here's my two congruent sides. Two congruent sides. There's for my one triangle. And then here's for my other triangle. Okay. Where are those two congruent sides meeting up? Right here. And right here. That makes sense. Again, it doesn't make sense to mark it up here at D. Why? Because this says that the angle is not where the two sides meet up. So it's at that section right here. So how do I name this angle? Well, think back to chapter 1 when we actually named angles. There was two ways to name angles. There was just naming by the vertex. So like in this case here, if I was naming the one on top, I would just say that's angle D. But if I look here where the E's are, they're shared between both triangles. So I can't just say, well, angle E is congruent to angle E. I have to use the three-letter method. I have to make sure that letter's in the middle, and then my other two letters are my directions I'm going here. So if you recall, to name this angle here, the top one in black, this is angle DEF. Again, E is in the middle, and then D and F are the other two letters here to help create the vertex. Is congruent to, and then to name the one on the red, angle FEH. I could have flipped it. I could have said angle HEF, but as long as E is in the middle and I use the H and F here, I'm good. And that's how I go about utilizing these directions here. So look at a couple more. Number 10. Again, what else can I mark down here? I can mark down IJ because that's shared between the two triangles. I don't need to mention that that piece of information is missing because I know it's there. It's not missing, it's actually there. So if I look, what is marked actually between both triangles? Well, I actually have one angle and one side marked up. So what I'm missing is another side. So the question is, which side am I missing? Is it HJ or is it HI? And then does that correspond with IL or LJ? Remember, in order to be SAS, the sides must meet up with each other, and that marked angle must be where they meet up. So let me ask you guys this: could it be? I don't need that. Could it be HJ and LJ? Hopefully you said no here, because again, if I was to trace this out, this is where the congruent sides meet up, and this is where the congruent sides meet up. Are the marked angles where the two sides meet up? And the answer is no. So these aren't the two sides here. So where are the two sides? Right here. HI, IL. Because again, if I mark down, or if I trace out where the sides, congruent sides meet up, the marked angle is there. So HI is congruent to IL. Alright, let's go to the next page here, and we'll do two more together. Okay, number 11, want SSS. Is there anything else I can mark down in number 11? Hopefully you said no. There isn't anything. There's no shared line. There's no vertical angles. So what am I given here in both triangles? I am given two sides. One here, matches up with the one here and one here. So I'm missing my third side. Now I'm circling one of the S's here. It really doesn't matter which one it is, but I'm circling what I'm missing. In all honesty, this one's pretty simple. If I'm missing the third side, which is the third side that needs to be marked? It's these right here. I don't need an angle. Nothing says here that I need an angle. It says I need three sides. So VT is congruent to WY. Alright, number 12 here again, it wants SSS. Anything else I can mark down? Yep, I can mark down AC. So I'll mark that down. And since I want SSS, I'm missing a third side. Again, I see many students, they start marking these angles here. And for whatever reason, I don't understand why, but they do. And who cares? They don't ask you for that. If this was asking for SAS, then yeah, you'd be right. But we're looking for SSS. And besides, nothing can tell you that those two angles are congruent. Nothing. So I'm missing another side here. So what's the third side I'm missing? Right here. BC, AR. BC congruent to AR. Alright, ladies and gentlemen, so that's basically what you have to do with these problems here. And you do actually have to write it down. You have to actually say some line or angle is congruent to some line or angle here. Marking it down just helps you visually. Marking it down is not the final answer. If you look into the directions, it says actually state what you're missing, not mark down. Alright, so try the rest of these here. Once you try the rest of these, if the sub has not already, then you can start on your, it has not passed out already, ask the sub for your homework, the other homework sheet that you need, and you can start on that. It's just 10 more problems here. I believe it's 4 like the first section and 6 like these here. For number 13, just one thing I want to clarify. If you notice, it has 2-letter P's. Make the right P an S so that we can just clarify the different line segments. Alright, so again, ladies and gentlemen, you need to finish this worksheet, the notes and practice problems here, and then the sub will give you another worksheet that says SSS and SAS triangle congruency theorem, I believe. 10 problems on there. That will also be for homework. So both of these will be for homework, and I will check it the next time we have class together. Again, if you have any questions or concerns, please feel free to email me, and I will get back to you as soon as possible. This is Mr. Kizik signing off.